going to talk about triangle similarity. In the past, in other math classes, you've talked about triangle congruence, which means setting up rules to know on how you know how two triangles are exactly the same size. Today, we're not concerned with same size, we're concerned with same shape. For instance, if I had a triangle, say that looked like this, and then I were to copy that, those two triangles are what we call congruent. They're the same in every way. All the sides, the matching sides are the same size, and the angles are all the same size. The corresponding angles are the same size. But if I take this triangle and I make it smaller, but I keep the ratio the same, now the angles still match. But now the sides are different lengths. These triangles are called similar. Anytime you take a shape and you make it bigger or smaller without changing the aspect ratio, then that would be similar. For example, I drew a picture of me. It's me, big head. And then I drew another picture of me where my head was the same size, only I was shorter. Are those similar? No, because we've only shrunk in one direction. All we did was made it shorter. Those are not similar. If you shrink vertically, you also have to shrink horizontally. And more than that, you have to shrink by the same percentage. If you cut the vertical in half, you have to cut the horizontal in half. And whenever you have similar triangles, let's say that this is 10, 15, and 5, the other sides are going to be proportional. So let's say that this side here is 5. What would that side be? Well, don't trust the picture. It looks like they're the same, but don't ever trust a picture in geometry. So if this side is 5 and it matches up with the 10, what would this length need to be? 7.5. Half of 15. So 7.5. Okay? So if this side is 5, what would that side be? 2.5. And if you notice, 10 divided by 5, which is this ratio here, is equal to 15 divided by 7.5, this ratio here, which is equal to 5 divided by 2.5. And since all three of those have the same value, those triangles are similar, meaning the shape is the same, but the size is different. If I were to blow up that smaller one, make it twice as big, it would be the same as the bigger one. So if you take a look at your worksheet, we have two similar triangles. How do I test these for similarity? How can I verify that they are in fact similar? Right, and how do I know which sides to match up with the other sides? Oh, don't trust the picture. So you can't look at it and say, oh, this one looks this way and this one looks another way. But there is, what's that? Look at the measurements. What side matches up with 9? Why 3? It's the smallest. 9 is the smallest, and 3 is the smallest. So 9 over 3. What are the other fractions we're going to set up? 12 over 4 and 15 over 5. Are all three of those the same? 9 divided by 3 is 3. 12 divided by 4 is 3. 15 divided by 5 is 3. So the big triangle is 3 times bigger than the small triangle. And because that's true with all three sides, the triangles are the same shape. Now, what if instead of 15, this one was 16? If I mess up one side, does that ruin the similarity? Yes. So we call this side, 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 similar. And we have to write the word similar, or at least the abbreviation similar, because we want to remind whoever's looking at this that they're not congruent. They're not the same shape, they're not the same size, they're merely the same shape. But there are two other rules. So that's one that you're going to use. The other one is really easy. Well, it wouldn't be a triangle, it would be a quadrilateral, and those are a lot more complicated, so you won't ever see that. These rules only apply to triangles. So over here, let's say that I knew this angle matched that angle. Does that guarantee that the triangles are the same shape? If one angle matches? No. What about two angles? Well, if I know two angles in a triangle, do I automatically know the third? Why? They all add to 180. So let's say this was 40, and then this one was 60. 40 and 60 is 100. How big is the third one? 80. So if two angles match, does that guarantee that the third angle matches? Yes. And if all three angles match, does that guarantee that the triangles are the same shape? Yes. So this one is called angle-angle similarity. If you're looking at two triangles and you know two angles, two sets of angles are congruent, that guarantees that the triangles are the same shape without even measuring the third one. So that's the easiest one you're going to deal with. The other one involves knowing one angle. And you know both of the sides attached to that angle. So let's say this one is 8, and this one is 6. And then over here, this one is 12. And this one is 9. So this is called side, angle, side. Meaning, we know two sides, and where does the angle line up between, in relationship with those two sides? If I write side, angle, side, it means I know two sides and the angle between the two sides. That's different than, say, side, side, angle, or angle, side, side. Those are not the same thing. Shiloh's, she's giggling. Try not to giggle. So side, angle, side means you know the angle between the two sides. But just the fact that we know two sides in an angle isn't enough. We have to check to see if they're proportional. So what fractions am I going to create here? Eight matches up with 12. What's the other one? 6 matches up with 9. So divide each of these by 4, and I get 2/3. Divide each of these by 3, and I get 2/3. So because this one matches that one, and I have side, angle, side, those are similar. So side, angle, side, similar. So if you look at the next page, does number 1 fit one of the rules? So I do have side, angle, side, but I need to check proportionality. What are the fractions I need to test? So small and small, those two match. Big and big. So is 4 over 10 equal to 5 over 12? This one is 2/5, and this one does not simplify 5/12. So just because you know two sides and the angle between them, that's not enough. You need side, angle, side, and you need to test the fractions and see if they work. So number 1 is a no. What about number 2? Yes, by what rule? Angle, angle, similarity. So number 2 is yes, they're similar. The rule is angle, angle, similar. Okay, how would you do number 3? We have to test all of the fractions. So I'll put these in order from small to big. 2, 3, 5. And then on the other triangle it would be 6, 9, 15. This fraction simplifies to be 1/3. This one simplifies to be 1/3. And this one simplifies to be 1/3. So this is similar. What's the rule? Side, 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 similar. That's what you're going to do on the rest of this page. Go back to the first page. And there's a mistake on this page, sorry. This 12 needs to go right here. Otherwise it doesn't work. All right. So the instructions say that we know the triangles are similar. Now we need to find the value of x if the triangles are similar. So I'm going to do 15 over, what side does 15 match up with? Is it x or is it 6? Take a look at the angles. 15 is between the blank angle and the single angle. So if I go to the other triangle, blank angle, single angle, so 15 matches 6. And then what do I put on top? Does it matter whether I put 20 or x on top? Yes. Which one is it? 20. How come? We're going from this triangle to that triangle, and you have to keep that order. So if 15 goes on top, then 20 is numerator over x. Now if I have two fractions that equal each other, how do I find x? Cross multiply. So I times those two together, and I times those two together. 120 equals 15x. Divide by 15. X equals 8. So 8 is the only number that can go in that spot to make the triangles similar. Okay. The next one's a little bit harder. X plus 3 matches up with what side? 10. So x plus 3 over 10 is the same thing as 18/12. Cross multiply. 10 times 180, or sorry, 10 times 18 is 180. How do I do x plus 3 times 12? What is x plus 3 times 12? 12x plus 36. So you do x times 12, which is 12x, 3 times 12, which is 36. Okay? Now we subtract 36, and I have 144 equals 12x. So x must be 12. Okay. So that x would be 12 in order. for those triangles to be similar. All right, now down here, these two triangles are similar if the lines are parallel. And I'll show you why. If I extend these out, and I say that they are parallel, how would you describe those two angles? They're corresponding. So if the lines are parallel, then those two angles are the same. What other angle? We have to have angle in order to guarantee similarity. So these are also corresponding. So those are equal. Or, if you notice, that angle is shared in both triangles. So no matter how you look at it, you have angle, and the triangles are similar if the lines are parallel. Now, from here on out, if they look parallel, we're just going to say they are parallel. So, 6 over not 4. 6 over x is equal to 8 over 4. Now, I don't even need to do the cross multiplication to figure this out. What answer for x is going to make this equality true? Half of 6, which is 3. 4 is half of 8, so x has to be half of 6. So x is going to be 3. And a lot of times, it's that easy. You can just look at it and say, oh, I see the pattern, and then just multiply or divide by a particular number. Okay, this last one is tricky. What would your first fraction be? 20 divided by 15 equals... Now, a lot of you want to do x over 12, but that's not right. Let me show you why that doesn't work. So 20 is the left side of the big triangle. Everybody see that? 20 is the left side of the big triangle. 15 is the left side of the small triangle. Right? How would you describe 12? Right side of the small triangle. And so this one would need to be the right side of the big triangle. Is x the right side of the big triangle? No. Here's the big triangle. So the right side of that triangle is this piece here. X plus 12 is what you need to use. Nope, you just put it over 12. So what you're doing is dividing this length by that length. And you can see 15 and 12 match up because we have left side and right side. And then 20 matches up with this big length, x plus 12. Now, there will be one of these on the test, and this is the question in this chapter that people miss more than any other. Because on the problem before, 6 and x, 8 and 4, it matched up just fine. But on this problem, the 20 matches up with the whole length, which is x plus 12. So if I cross multiply, 20 times 12 is 240. How do you do 15 times x plus 12? 15x plus 15 times 12 is 180. So 15x plus 180. Now we subtract to the other side. So 60 equals 15x. Divide by 15, and we get x equals 4. Now it's really obvious to see if 15 matches up with 12, 20 can't possibly match up with 4. because 4 is smaller than 12. But 20 does match up with 16, which is a whole length. Okay? So you look at the second page down at the bottom, you need to create your own triangles. One of them needs to work according to side, 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 one by side, angle, side, and the other by angle, angle. Then on the last page, you're just finding the value of x that makes the two triangles similar. Okay? Should have plenty of time in class to finish this. Good luck.